just want to say one word to you. Just one word.
Yes, sir.
Are you listening?
Yes, I am.
Plastics.
Exactly how do you mean?
There's a great future in plastics. Think about it. Will you think about it?
Yes, I will.
Enough said. That's a deal.
Plastic. It's durable, lightweight, it's weatherproof, easy to process. You can melt it down, you can remelt it into a billion different things. Our society, like these properties of plastic, has meant our society has become reliant on it, almost addicted to it. It protects our food. It allows us to climb mountains with waterproof clothing. It reduces emissions in transport through lightweight but strong materials in our cars. Yet it's killing our world in two ways. Firstly, it's made from fossil fuels. And secondly, it's synthetic. So it generates persistent pollution in the environment, killing wildlife, and then eventually breaking down into microplastics, harmful microplastics that wind up inside our bodies through the air we breathe and the food we eat. Uluu has developed a replacement for plastics that gives you all those properties you like about plastic whilst generating positive rather than negative externalities during production. And this involves two things. So firstly, our materials are produced or built by nature, essentially. Nature understands it, nature can break it down, but they behave like plastic. And then secondly, we use seaweed as a feedstock. All materials require a carbon feedstock. We use seaweed rather than fossil fuels or hydrocarbons. And yeah, so in more detail, these are the microbes that produce our materials. They're called technically PHAs, and they're those white nurdles inside this cell. It's kind of like their fat storage. And to commercialise PHAs, we take PHA-producing microbes from the wild and we bring them into the lab and feed them in big vats called fermenters. It's kind of like brewing beer, but we're brewing an alternative to plastic. And PHAs are unique. They're very rare in nature in that they actually have properties that behave like plastic. And then that's where the seaweed comes in. So we feed those microbes seaweed, so it's our feedstock. And rather than using waste streams or land crops like cornstarch, we believe seaweed has what it takes to scale sustainably to actually decouple our materials economy from fossil fuels. Oops. And so by combining those two unique things, by combining those two things in a unique way, so using seaweed to produce PHAs, we can replace plastic at scale while doing good things for the world. And that's really three things. So firstly, tackling plastic pollution, and that's because our PHAs are home compostable and will also biodegrade if they happen to get into the ocean. Secondly, they mitigate climate change, and that's because we use, obviously, seaweed, which absorbs a lot of carbon from the environment. In fact, we offset more carbon than we emit through our production process. So we have a carbon negative production process. And then finally, that seaweed is also great for the ocean in which it's cultivated. It absorbs marine pollutants, things like runoff from fertilizers and sewage, and helps to clean the water as it grows. So it's a feedstock we really want more of in the world. We want to scale up seaweed farming. How do we turn seaweed into PHAs? Firstly, we farm seaweed. We then extract the sugars from that seaweed and we feed them to these microbes in fermenters. They grow this PHA, and once they're fat enough with PHA inside them, we extract it and we melt it down into pellets. And pellets are manufacturers today currently purchase from petrochemical companies. There's around 400 million tonnes of pellets produced every year, That's more than the amount of meat that we consume. And at Uluu, we want to replace these plastic pellets with Uluu pellets. We want to replace the petrochemical companies upstream in the supply chain. And that's what these pellets look like. And essentially, yeah, by entering this point in the supply chain, we're kind of like the... hopefully, yeah, you can hear me again. And I will show you some images to show you where we're at with Uluu. So we purchase seaweed farmed in Indonesia, and Indonesia is the world's second largest producer of seaweed, and 65% of those farmers are female, and we're really enthusiastic about working with them. We've established a joint venture in Indonesia, building have established a joint venture to source or build transparent seaweed supply chains, seaweed, but also to other off-takers. We then take it, process it, and this is our Indian Ocean Marine at the Indian Ocean Marine Research Centre. This is Chris cooking our seaweed, extracting the sugars from it. David fermenting those sugars into PHAs. We extract the PHAs and they have this really nice pink colour before they turn white after washing. And this is Reza compounding our PHAs into different grades of pellets. This slide shows the versatility of those materials. So on the left, we have a melt press film. In the middle, an injection molded rigid disc, a test disc which we send to customers to do trials on. And then we can extrude them into fibers to replace things like polyester in your plastic clothing as well. And what's important here is that we can use existing manufacturing facilities, so plug and play with existing processing equipment, which is obviously really helpful for adoption and scale. Our revenue streams are quite interesting. So we have two. Firstly, pellets, obviously, so injection molding grade pellets, and then also fiber grade pellets. And then seaweed is amazing. It doesn't just contain the sugars that we use for fermentation. It also contains proteins and fats or lipids. And when we extract those sugars, we're left with a protein-rich leftover biomass that contains a relatively higher percentage of protein, about 50%. And we can use this vegan protein to replace things like fish meal in aquaculture feed. And that's great because it generates an additional revenue stream, which is actually quite significant, but also helps us to reduce our carbon footprint further in that fish meal today is very carbon intensive. And that leads to this map showing how Uluu can not only help us to make plastic a thing of the past, but also animal proteins. By 2040, we aim to generate $200 billion in revenue by replacing 140 million tonnes of plastic and also 210 million tonnes of animal protein, all the while offsetting around 700 million tonnes of carbon pollution from our environment. And so to wrap it up, if the graduate was to be remade today, rather than the one word being plastic, we think it should be nature and nature-based factories and biology. So yeah, I'd like you to think about it.
Thank you.